Welcome to another edition of the Sim Racing Garage. I am Barry Rowland. In this episode, we will be reviewing the new 6S80 cockpit kit from the guys at 6Sigma. Constructed from 4080 aluminum profiles with black anodization finish. With beefy slot-type T-nut fasteners and large 8-bolt gusseted corner brackets, it looks to be capable of giving us a very solid performing result. Time to put it through the SRG's review process and see how it does. So, let's get to it. So let's go over the profile styles and the hardware we're going to be using and fasteners to assemble the base. Now, this is just a sample piece. We have two very long 1200 millimeter pieces of this type of profile. And we also have three 500 millimeter pieces that are going to be the spreaders in between those. Typically how we will be constructing a profile cockpit. Now, this is profile that's sourced in China. And all of the Asian profile, or at least I think all of it's come from China that I've seen, has a deeper channel profile than, say, something you get out of Europe or you get in the USA here or North America. And this has a shallower channel in it. Also, this is I think this one sourced this one from Europe. You can see how much more material there is in the middle of this, which is going to make it stronger and stiffer and heavier at the same time. I would call this a normal profile. This is what I would call light, because you can see there's less material in the middle parts. And then we have the ultralight, which is an example here. You can see how that's hollowed out in the side. Very light though. So I just want to show you the differences. Now, typically when I get these type of cockpits with the deep channeled Chinese profile, we get the T-nuts that are like this. And you can see they have this leaf spring on it, little piece of metal sticking on it. And this is spot welded on. Has 3 spot welds on it. Now this is obviously cheaper to manufacture than something like this, which it has a spring ball mechanism in it so that it will stay where it needs to be in the channel, just like this leaf spring one. And we can also roll these T-nuts into the channel without having to go into the end. So that means if I have a cockpit that's fully assembled, to attach something else, all I have to do is roll this T-nut in, and the same thing happens with this spring leaf deal. You can just roll it in. Now, this is what we're going to be constructing the base section out of, and this, you can see there is no spring function in this. It does fit the channel quite well. I'll show you that there. Keep it from sliding. So we're getting a lot of surface area contact here in the channel, whereas like the spring leaf one, it was made for this type of profile. Let me get it in there. There we go. You can see the surface area that's going to contact the channel edges here are not anywhere near as much as the surface area that this is going to contact, which is going to add strength to our connection, as you might imagine. But there's always trade-offs, right? There's always a compromise. So that means that I cannot take this T-nut, take this one out, and roll it in. Right? That's just not going to happen. So you have to put it in from the ends like this. So what that requires is careful management of the assembly process so that when you're assembling a cockpit like this that uses these type of T-nuts, then yeah, you have to make sure that you get all the T-nuts in the channel you want for whatever it is you're going to be attaching to that base. As long as it's on the outside, you're okay because we can just take an end cap off and slide it in, right? But once this is attached with a corner bracket, like this, let me show you how this is going to work. By the way, these are the corner brackets, heavy duty units, it seems. And these are painted, it seems like, aluminum jobs. You can see they have some slots in it and we have some holes. So it gives us a little adjustment there. A little bit of flexibility in the mounting. So they're going to sit in here like this. I'll have one here, and just using this as an example, we'll have one sitting in here like this. And that'll be our joints. Right, so we'll have a total of 8 bolts holding this in and 8 of these guys with the extra surface area to clamp down on, which is going to give us a very secure connection, as you might imagine. So, only problem is, let's say I have this connected or set up, and I have another one over here. I want to attach something in here. Well, this is not going to work for that, is it? Now, if we had the usual Chinese T-nut with the spring leaf in it, I could just roll it in there and attach it, no sweat, take it out the same way. This one, you can't do that. So I'm going to have to plan ahead to get this in there for when I need it. So if I'm going to be putting something else in there during the base assembly, I'm going to remember that and put enough T-nuts in to cover that connection for whatever it is I'm trying to put on there. Otherwise, I'm going to have to completely disassemble one of these ends, right? This bracket's going to have to come off, slide back out, and then I can put the T-nut in. And that means I'll have to attach this back on there like that. And of course, in the base that we're going to be building, there are 6 of these. So you have to pull one side of the base off, one of the, like a 1200 millimeter size. And I might discuss that again as I'm doing the assembly process. But yeah, but then again, I can't be too negative about this because it's a very strong connection when compared to any of these type of T-nuts because of the very limited amount of surface area. Even though they work, I never had a problem with these, by the way. Yeah, this is going to center itself in the channel. You can see the raised area in the center there and all that surface area that's going to be grabbing the channel. So it is going to be a stronger connection. But do you really need it? Yeah, that's debatable. Depends on what you're going to be doing with the cockpit, I guess. So anyway, we also have these 60 millimeter M8 bolts. These are steel. And we'll be using those, like, obviously with our T-nuts here. And of course, our brackets in the assembly of the base. So now we'll start building it. So these are the parts we're going to be using to assemble the base of our profile cockpit. We have a long 4080 piece here. This is 1200 millimeters long. You can see the other end down there. And I've kind of finger tightened the T-nuts so that they don't slide around while I'm moving things around in here. So they just don't slide around, even though I can just loosen them up and get my final adjustments as I'm putting these pieces in. Now these are the 500 millimeter spreaders or stretchers, whatever you want to call them, that go in between our long 120 millimeter profiles. Typical of how we construct a cockpit. Now, this is going to sit on the back over here. We're going to have another one sitting up here. In fact, let me just kind of lay this here. Take this one and put it here. And then we're going to have the other one over there on the front part. So that's going to seal up our rectangular box, if you will, and this will be however it's all constructed. Now, one consideration here is how you're going to do this. I decided to do it, put the brackets on the long pieces first, and then I can come in and just slide the whole 120 millimeter piece up against these spreaders and feed them into these nuts into the channels as I'm doing that, like that. And do the other one and then do the other one. Then I'll come on the other side, once these are in, and bring the other 1200 millimeter piece in, again with the brackets already on it, and just feed it in there. And then we'll make our adjustments on the width and where everything needs to be, and then finally tighten it down. Now, before we bring the other side in, because we're going to have seat rails on top of this, so that's going to be mounting our seat to this stuff, right? And they are 400 millimeters long. So we're going to be mounting these. They're going to sit like this. So they're going to be kind of high, actually. This is going to be 80 millimeters high. You could do it this way if you needed your seat to be lower. So you can do it either way. I'm not sure what I'm going to end up with. But the important thing here is, because we're going to be mounting these, we're going to need some T-nuts in these channels. And I'll use this 400 millimeter long piece to simulate the 1200 millimeter piece we'll be using. Then, yeah, I can't get a T-nut in now, can I? Because these are not the twist-in T-nuts. So I would have to take it back apart. So this is where you want to pay attention again to the build process, so that I can take these T-nuts, preload them in this profile like this, before I come in with my 1200 millimeter piece and kind of seal it up, if you will, to where I can't get access to the channel unless I use one of the twist-in leaf springs, which that's not how this is assembled. So this is what we have to work with. So we want to make sure that you get that in there, and then we can come in and attach these and put our brackets in. So just something to be mindful of as we are getting everything set up to assemble the base. So with that said, all we have to do now is go ahead and get all this gear on the floor and see how this goes together. So I already installed one side with all 3 of the 500 millimeter pieces attached to the 1200 millimeter piece. And I'm going to show you me putting in the other side because it's just repetitive. Now, I did take time to, as I was putting these on here, to take the 400 millimeter long seat rail and put it up here so that I could gauge where it needed to be as far as this middle piece. Here, the back 500 piece is going to be level with the edge back here. So that was a set. We didn't have to worry about where that was going to be. We knew it had to be at the end. But here's where you have to adjust back and forth. No big deal. Just slide it where you need it and go ahead and cinch it down. And everything is just barely tightened down just to hold things in place for me as I continue on to the other side. These are 6mm wrench size for your hex heads on these bolts. And now I'm just going to go ahead and slide this section in. And one more thing to note, remember we still have a pedal tray to put in here. So we're going to need to pre-install a T-nut in the top channel of both of these 1200mm pieces. So don't forget that, because remember, if you do forget it, you're going to have to come back and take this back out and slide these end pieces out and then put them in and then bring it back in. So go ahead and do that from the get-go and you won't have to worry about that at all. So without any more further ado, we'll go ahead and start putting these in. Now this one I'm going to have to slide. I think I got these things finger tight in here just to keep them from sliding around too far. I'm going to slide this one over here and we'll go ahead and loosen this one up. Slide it in a little bit. And you kind of have to gauge this as you're putting them in. Remember, all three are going in at once, so we are going to be juggling things around a little bit. All right, so it's not that hard. It's just, you have to be patient and kind of jiggle things a little bit, and they'll go ahead and slide in. Also, you want to make sure that you have your T-nuts not too far onto your bolts. You want there to be plenty of room in between the back of this bracket here and where you're going to put your T-nut into the profile itself. You don't have enough, it's going to stick. So I always go in there and look at them and make sure that I have enough room. And even so, you might experience a tight one. You have to turn it a half a turn or so to get it to go in. So I'm going to go ahead and start wiggling this in. I'm going to start with this side. And I kind of have things lined up visually looking straight down here so that I don't get stuck somewhere. So once I get these first one started on the back here and on this middle section, and I feel like they're not going to fall back out, I'm going to go down here. Now I'll do a close-up on this so you guys can see what's going on. It's just getting the T-nut straight so that they'll go into the channels. Pretty simple stuff, really, when you think about it. And I have this one loose, obviously, so it shouldn't bind on anything. So I'm just kind of jiggling them, get them to start. Now that I know that both of those T-nuts are all the way into the channels, I'm going to go ahead and come back down here and just jiggle it around a little bit and see if I can get them to go in. Now again, I might have to loosen one or two of these up if they're too tight and binding on me. Just sliding in pretty easy. Okay, so now we're going to go get these back ones. Now the back ones are kind of cool on these brackets because remember these brackets have these slots in them on the middle inside part. So there's a slot on each side, 2 slots each side of this bracket here. So when I'm putting this in, you can slide these pieces in further. So you can just kind of slide them in other words. You don't have to slide everything up at once. So individually, I can come in here and slide those T-nuts in just like that. And they're in. Now, if it had been separate holes, then I would have had to slide everything in together. But this allows me to have a little freedom here when I put this in. So I can actually take this and slide it up because of that channel without moving the side profile relative to the front piece here. We'll go ahead and get those in. All right. And I'm watching the profile edges here. Make sure that they're going to line up the way I want them to. That feels about right there. And now once it's all done, of course, it's just a matter of tightening things up again. So I just go down here. Now I like to tighten the insides up first. I'm not going to get them real tight yet because this tends to bring in this corner here will self-center around this bracket. This bracket is 90 degrees, so it will give you a nice flush setup on the profiles on the front and the back if you pull them on the inside first, not the outside. And remember, we have 8 bolts here, so this is, it's going to be a little repetitive having to get them all tightened up. But I think it's going to be worth it in the end. The way this is working with these T-nuts, as you might imagine, this is going to give it a lot of strength in the corners, whereas really where we need the strength. So these slid out a little bit. I'm going to come back and get to the back one, get it where I want it, and snug these guys up. Again, I'm just careful about what I'm doing. I'm watching the brackets. I'm watching what's going on as far as the profile and how even it is with this profile over here. It's just a little dance you have to do, but once you get it going, yeah, it's pretty easy. Go ahead and do this one. Again, insides first, because I want to draw this angle in. Make sure everything's looking good and straight there. Piece of cake. Now I just need to go back and get everything nice and tight. I'll go back and check my angles again and make sure everything looks flush and where it makes me happy. So, and everybody's a little different on how particular you're going to be about that. I'm pretty particular about it. I like everything to be nice and flush. And again, I'm going to check my seat rail. Hopefully, it's the same distance over here. And it should be, because again, once we tighten up these corner brackets, they are a perfect 90 degree, or they should be a perfect 90 degree angle here. So it makes a perfectly square box once you tighten it up in the correct sequence. So I get to the inside ones first, and then I'll tighten the outside ones later, because that's what really is going to give me the angle I want. And that looks perfect. All right, and we'll talk more about the seat brackets and mounting them in another segment. So that went pretty easy, really. And yeah, let's go ahead and get to the next segment. Now we're going to put our feet on the bottom. Even though we've got the cockpit bottom section or base built right now, we left the end caps off. I'm not going to put those onto the very end of the build. And you can still slide these T-nuts in from the outside, because this is going to be an outside access. This is our side rail, and we're just going to slide them from the end right into the bottom. Now, the foot itself has a nut attached to it, and this is a 13 millimeter nut. And the foot itself is just kind of a hard plastic piece, kind of a generic looking foot here. Got some holes on the other side, and we have a threaded rod protruding. And this nut has a threaded flange on it. And what that's going to do is lock into the bottom. So this will be an adjustable height mechanism the way this is set up. We just put the nut on like that, run it down, then we're going to put the T-nut on like that. Leave plenty of space in there so we can slide it in here. I'm just going to slide them in like this. Pretty simple. And then once I have all of them in, I'll pull the cardboard out from under the cockpit, let it sit on the concrete, and then I can adjust each one independently so we can level it out in case there's imperfections in the concrete floor that I have here at the SRG. So pretty simple stuff, real. Just 3 on each side, and you can actually screw this all the way down and it'll lock it in position where you can't move it. But because that nut is in there, this will give us an opportunity to raise and lower it a little bit, and then we'll get in with this wrench here. Now they supply you this wrench, which is a 13 millimeter on one side and a 14 on the other. Very low profile, thin, so you can get in here and get to these nuts and adjust it. Pretty simple stuff. We're going to go over to the cockpit. I'm going to flip it up on its side, slide these puppies in and attach them, and when we come back, we'll see how that went. So the feet are now installed into our 1200 millimeter side profiles. Again, just turn it up on its edge and slide them in. Pretty simple stuff here. I did space them out as evenly as I thought they should be. And yeah, just slide them into the channel. Because we don't have the end caps on yet, we have easy access to those channels. Probably the easiest part of this cockpit build. All right, so we're going to install the pedal tray next. And this is a stamped steel pedal tray. It is 2 millimeters thick stamped steel. We have a configuration of slots in here that allow us to mount certain pedals to this. On the sides, we have the adjustments slot here, because we're going to be mounting this on these brackets, and we'll see those closer in a minute here, to the back part here. So as we raise this on the pivot point, and this is the pivot point that's going to sit on that top channel on those 1200 millimeter pieces of profile that we've pre-installed our T-nut before we put it together. And if you've been watching so far, you know what I'm talking about. And this will be for changing the adjustment back and forth. Now, there is some reinforcement under here. Now this, first off, before we get to that, this tray is meant for, and they have a list on their website. This is for the Fanatec's, the Thrustmasters, the Logitech's, pedals like that. That's what this is intended for. And being 2 millimeters thick, yeah, I probably wouldn't want to put my SimTrek stiff pedal on here. It would probably bend it out. It would flex as I put the pressure that I usually put on my brake pedal on there. So it really wasn't intended for the really heavy-duty pedal sets out there. So let's go ahead and look at the bottom, how they're making this. This is stamped steel, and it folds over, and you can see they put some welds in here. It's a good shot of that weld. There it is. There's a little bit of it there. They grind it down and then they paint the whole thing. So there's welded on the corners, all 4 corners. Then we have these bars here. And these are rectangular bars. They are hollow. They're not solid. And they have some spot welds on both sides of them. You can see on the top and bottom there. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14 for the top ones. So that's 14 welds per bar, which is a good density as far as spot welding goes, I think. Of course, I would rather see a solid weld all the way across here on both sides. But I'm not even sure if you did that, if the metal, because it's only 2 millimeters thick, could withstand the heat that would generate by getting a solid weld across there. But yeah, for what its purposes are, it's probably going to do fine. Just like I said, I wouldn't be putting a heavy-duty set of pedals on this because I would expect it to flex. But I do have a little trick to throw at this plate. I do have a Logitech pedal set that I installed a True Brake mod a long time ago on, which makes the brake pedal very stiff. So I can put a lot of pressure on that brake pedal, and it gives that pressure feel like a load cell. But it is not a load cell, but it just gives you that same kind of feeling. So I'll still be able to put some pressure on it. Now, what else do we want to talk about here? These brackets. They're going to mount to the front of the 1200 millimeter profiles. And we'll have one on each side. And let me turn this back over here so we can see what we're doing. And remember, the front holes on this right here are going in the top channel of the 1200 profiles on the inside, where we have that T-nut. On the back, it's going to sit like this in these brackets. And the brackets will mount, let's see, like this. Yeah. Like this. So we have the angle pointing to the front of the cockpit. Like that. And this allows us to adjust the height, and we'll see this better once we have it mounted, obviously, to adjust the height up and down like this, right? And as we do that, that was close, yeah. As we do that, of course, it's going to change when we're lifting it up and down. It's going to pivot on the front point down here, and of course, it's going to change the location in this slot. Now, the slot itself, we have one of those bars, and you can see the hollow bar in there, right? So it's kind of in the way of a complete movement there. So if you have to get closer, your angle makes you get on this side of it, then you'll have to just move the nut that you put on it. And what nut are we going to use? Well, guess what fits into these things? Like a champ. These big fat T-nuts, which is going to give us some good strength in there. So what we're going to do is, at least this is how I'm going to do it, is I'm just going to put the T-nut in there like that. And you see how it fits in that slot? So it actually moves back and forth. Once you have it loose, it'll move back and forth. And then, of course, I'm just going to use an M8 bolt over here, and that will go through the bracket, of course, first, and then go into that, and I can move it back and forth. Just like that. Really easy stuff here. So what we'll do is go ahead and go over to the base that we've already have built and attach this, and yeah, see what it looks like. All right, so the pedal deck or pedal tray, what do you want to call it, is now securely mounted. We have our M8 bolts on the single holes up front here on either side. And of course we have that T-nut that I showed you on the bench in here on both sides and another M8 bolt. And of course that's going to allow us to adjust the rake up and down. I already have it adjusted to what I'm going to be using on the pedal sets. There's also 2 T-nuts that we put on each side of our 1200 millimeter long side profiles on each side, and that allows us to move everything when it's loose, and I have everything loose. We can actually move it back and forth. So if I need to, well, let me just do it this way. I can slide it back and forth for my pedal reach, and that'll go the full length of this cockpit. So that's good because you can dial in your pedal position pretty easily here. And then it's just a matter of tightening up a few bolts and we're good to go. So everything went just like I thought it would. No surprises, no gotchas. So yeah, we can call this one finished. Now it's time to install our seat rails. Now these are 4080s, 400 millimeters long, and yeah, the way they have these things to mount to the rails that are crossing. So let's say this is the 500 millimeter rail that's crossing in our cockpit down there, and they sit like this on both the rear one and the one in the middle, or one's towards the middle anyway. And this is going to give you an 80 millimeter height on your seat brackets before you even attach your brackets or your sliders, whatever it is that you're attaching. You can mount it that way, like the instructions say to, but you can also mount it flat and cut it down 40 millimeters on the height if you need to. And this is the way I'm going to install mine, because I already know that the way this pedals are going to be sitting on this cockpit, I'm going to want my seat to be as low as possible. And that's why I'm going to lay it that way. It's not going to affect the sturdiness or anything like that. It's just as sturdy attaching it this way as it is that way, because we're using the same brackets, the same fastening hardware. Speaking of which, we'll be using our familiar beefy T-nuts. And we'll be using these guys. These are flathead M8s. And that is a 5 millimeter wrench size on top of that. And they do give you some hex, the generic hex wrenches in the kit to use on this. And then we've got these guys, these little brackets here, kind of a little aesthetic loop on the top there. And they are gusseted. You got these little gussets in here to make them stronger or add strength. And we have a flathead going in on both sides here. Now there are no location tabs on the bottom of this, which even if there were, you could get the location tabs in the bottom ones, looks like, or maybe even not even the bottom ones. Let's see, if this was the bottom one and we put this guy on the top of it like this, yeah, we could get the location tabs on the bottom slot here, but we wouldn't be able to do them on the top anyway, where they attach on the top part. So yeah, nothing special here. Aluminum, looks like it's painted. And yeah, pretty simple what we're going to do here. We're just going to put these T-nuts are going to go into these channels right here. We already have T-nuts installed on our cockpit where they need to be installed, because remember, we pre-installed those when we assembled the base itself. And if you've been watching to this point, you know what I'm talking about. All right, so we'll just go ahead and get over there and get this assembled and yeah, see what we got. All right, so here's what I ended up with. The seat rails are attached to the 500 millimeter crossing sections, and you can see I laid them down flat so that they are only 40 millimeters tall. So when I put my seat on there, it's going to get me closer to my pedals as far as my butt and my heel of my pedals being on the same plane, which is where I like to be as far as driving positions. And I think I'm going to be able to get pretty close here, which would be a big bonus for me, because sometimes I get in cockpits and yeah, there's just no way for me to get it out of the truck driver position, as I like to call it. Everything mashed up pretty good here, because we obviously already installed our crossing pieces when we assembled the base, using one of these profiles as a template so we can get our distance correct, and it's still there. Everything looks good. And I could take these brackets and move them into the inside if I need to come out further with the profiles. I don't know that yet. Once I get the seat mounted, I'll be able to find that out. But you can do that, and it's not going to affect the performance or the stiffness of your mount if you take these brackets and flip them over to this side and install them on this side of the rail, and that gives you a little bit more width if you need it. If you don't, no worries. All right, so now that we've got the seat rails attached, we can move on to the next segment. Now it's time to get our wheelbase support profiles mounted, or uprights I like to call them. And these are 600 millimeter long pieces. Again, the same 4080 we've been using throughout the build. And we are going to use these brackets. Now these are 10 millimeters thick, aluminum. They are painted. We have 4 holes that are countersunk on one side, like this one. And you can see I've already got some bolts in this one. And we do that because they will sit flush. And once they go into the profile, we'll be mounting this side to the 1200 millimeter long profiles on our base that we've already built. And then we'll be using these holes to mount it to that. So we won't see these holes anymore. We call these blind holes. And the reason we call them blind holes is because once we mount this securely to this profile, use this as an example. Let's see, I mount it right here. Then I'm going to go mount it over to the piece of profile that's, and this is what this guy is, right? I'm using this as a substitute for that. And then we mount this, we're going to use these outside holes to mount it to our 1200 millimeter long profiles, which means we no longer can see the bolts that we have sitting in there. That's why we call them blind holes. And to adjust the height, if you want to adjust the height lower or something like that, you would have to remove this to do that. That's one of the drawbacks of this kind of bracketry, but it doesn't bother me personally that much because I always mount these flush with the bottom and get the maximum length I can out of it. What I mean by that is, when I mount this bracket, I always mount it down here, like this, flush with the end of the profile. So I can take advantage of the full 600 millimeter length of this as far as adjusting my wheelbase up and down. Better to have too much than not have enough, right? But then again, if you want to fine tune it, you can always move this again and then take it off, move it, and then put it back on. But usually I find that just mounting at the end here suffices and you don't have any problems. So what I'm going to do now is mount this bracket onto the profile. And I usually take this, I'm going to do this on the bench, obviously, because there's no reason for me to try to go over there and sit on the floor and do this. So what I usually do is I'll get on the back here and I can look straight down and see these T-nuts and their orientation as far as if they're in the right orientation to enter the channel. And that's all I'm doing here, just look straight down. In fact, I think I'll flip this around here and just use this one. And remember, you want to make sure you get it this way, not this way. So now I can get down here, slide this down, and just manipulate the T-nut so it's where it should be to get in the channel. We have to get the bottom one also lined up at the same time. This can be a little fiddly. It's not too bad normally. And you can see that's going on in now. And then we'll do the same thing with the following, which is actually, they're easier because we already have two of the T-nuts located in the channel, so these usually go in pretty easy, like that. And there we have it. So now I would go down here and make sure that I am flush with the bottom of this piece of profile. I will securely tighten these down, give them a final torque down, because like I said before, once I have this mounted to the profile, I won't have access to these anymore. So you want to make sure you go ahead and get these torqued down properly. But again, we have some good gripping area here on these type of T-nuts. So it's going to hold, once you tighten it down, it's going to hold very well. In fact, I like these. These sections of a cockpit build, I actually use these myself. Even if the manufacturer just has a bunch of spring balls in there, even though you may have seen me do in a review, load the spring balls, I actually have a bunch of these M8s that are like this. A little bit different because I'm using a North American or European type profile, which has a shallower channel in it, but still the same principle applies here. You're getting a lot more surface area contact on the inside of the channel with one of these than you would a spring ball or the leaf springs. So that's a good thing in this part of a cockpit, because you want this to be as strong as possible, because we're going to be putting torque on this way up here with our wheelbase, right? Whichever wheelbase that you're running, you're going to be putting torque way up here, which provides a pretty good lever way down here, 600 millimeters on the other side, right? So yeah, the better surface area contact we can get, obviously that's a good thing. So we'll go ahead and tighten this down. I'll go ahead and load up the other one, get it on. I'm going to go over and attach it to those 1200 millimeter profiles, and we'll see how that goes. Here are the profiles mounted to the horizontal 1200 millimeter side profiles. No drama here, pretty straightforward what we're doing. There's a couple of ways to do this. I could have preloaded the T-nuts and slid the whole unit down in the channel to where I needed it to be, but that's prone to scratching. So I usually will pre-install the T-nuts, slide them down to the channels where I think approximately I need to be, and then, yeah, come back in with the assembled bracket to the upright and just go ahead and insert the bolts there. You have to get down and look at the holes when you're installing these things, but it's not that much drama. Like I said before, pretty straightforward. And yeah, everything went smoothly. These are loosely attached now as far as to the 1200 millimeter pieces. Now they are securely mounted as far as the uprights to the brackets themselves because of the blind holes. Again, we don't have access to those, so we had to go ahead and torque those down to the final torque that I thought was proper. And now, yeah, we're good to go. Now we can move on to getting our wheelbase mount installed. 6 Sigma sent me 3 different mounts. that I can show you guys. This is the mount that comes with the 6S80, but you can order other mounts if you want them. And I'll show you those mounts after this one, but this is the one that comes with the kit. It consists of this mount here, which is a universal type of top plate on this. You can see we have multiple holes built for the usual suspects like the Fanatec's and the Thrustmasters, Logitech. It even has Moza's pattern in here because I measured it out. I said, well, that's unique. They actually can fit a Moza on top. And it's made of two pieces here. I have the top piece and the bottom piece. And you can see that there are, let me go ahead and show you how this is built. This is a 3mm thick steel plate. It's been painted. We have 3 welds across the top here. We have a couple of little spot welds in the middle here, where this plate is fitting against the top plate. And if we look over here on the sides, you can see we also have a couple of welds there on the sides. So we have the slots in this top piece, and we have slots in the bottom piece. And the bottom piece is also welded. You can see here, and that's where our mounting flange is, obviously. And this is access holes, so we can actually get bolts underneath here to screw on a wheelbase. Welds up here, got one back there, and the same thing is happening on the top piece here, where our flange is. Of course, we have a flange here. We can mount it. You can move it back and forth. And because we have this, we'll be putting a bolt, obviously, in this slot, too. I just have it apart so you can see what we can do. And this allows it to move up a certain amount. And it also allows us to pivot or change the angle of the wheelbase to what we need it to be. Seems to be well built. It's heavy in hand. The piece down here is actually 4mm thick on the flange part that we're actually going to mount to the top of our crossing profile up there. I'll show you that now. These two pieces, the brackets, and this is the actual mounting piece that we're going to be sliding down into the uprights we've already mounted. And this has some holes in it on the end that are threaded. I think you can see the threads there. And when it came out of the box, it had these flatheads already in those threads, so they don't get lost. And what we're going to do is take these brackets. Now these are 10mm thick aluminum, and we have some countersunk holes on the top. Then we have a series of holes underneath that, total of 6 in 3 different pairs. And this is going to fit in like this. And then we're going to screw it, obviously, to the end over there, like this. And once these are secured on the profile, then we'll come in and load one up with some bolts here. Now, these are longer bolts than the standard bolts that come with, let's show you here. This is the 15mm length bolt M8s. And these are actually 20mm, a little bit longer. And the reason is because we've got this 10mm thick plate that we're going to be putting them through and mounting a T-nut on the other side. I will be using the heavy-duty big T-nuts for this, so that once I bolt this down, it's going to be nice and secure in those uprights that are over on the cockpit already. I'm just going to slide this down. Once I have the whole assembly done, I'll just slide it down as one piece, and then we'll come back. Before I put these end plates on, what I'm going to do is take 4 more of these. I'm going to slide them in the channels like this before I put them on, so they'll already be in there, and I can use those because I want to use these also, because this is a critical part of the mount, is, you know, where the wheel bracket, or wheelbase bracket rather, is going to fit onto this. I want everything bolted up with these T-nuts because it's going to give it a more solid grip on everything than it will with the little leaf spring T-nuts. So this is again where I like to use the heavy duty stuff, or the thicker stuff. So what we'll do is we come back, we'll put it together and see how all that went. Now we're going to take a look at a couple of extra mounts that the guys at 6Sigma sent to me. And we'll start with this big heavy duty one here. This comes with their 120 and their 160 cockpits. And it is, as you can see, a front mount design. And it has a very thick plate on the front, 15mm thick. It is cut out in a pattern here with a slot, so it'll fit any front mount type of servo motor type of direct drive force feedback wheel out there. The Cole Morgans, the Midges, M sources will fit on here. The Sim Magic Alpha series, Sim Cube, things like that. It'll all fit on here. No problems. It's assembled. It's not welded. They have their own bracket that they have made for them there. And we have 4 bolts on each side here, each corner, that are bolting these 2 pieces together. Now the side pieces where the slots are that you would use for mounting are 10 millimeters thick. So not quite as thick as the front plate. Very similar to other profile cockpit solutions out there as far as the motor mount systems go. So yeah, very heavy duty unit here. I would have no problem or fear of mounting my Cole Morgan 54G to this and running it just like I would on the one I have on the cockpit that I run all the time. Now they also sent this one. And this is a deck type of mount, what they call bottom mount, a CNC bottom mount, or something like that. And it has a 10 millimeter piece of aluminum here going in between these 2 sides. And it has a similar bolt pattern assortment that you find on their regular mount that we're using over there on that 6S-80. That's the OEM mount. You could order this mount if you're going to run like a heavier motor. Now I'm running a Moza R9 with 9 Newton meters of peak torque, and the mount on there should be fine for that. And I was watching some video of me using it. It's really not flexing much at all. It's not moving much as far as the mount goes. And yeah, this would obviously be a little bit solid or more solid than the one that's on there now. If you're going to run something like a Moza R16, you know, I wouldn't run a 21 on this. I would, well, I guess you could run it, but I wouldn't run it on those 4080 uprights. I think I would want at least a 120 on that for the uprights to run something with that much torque. But yeah, 16, 15, something like that should be fine. And of course, they have their own mounts for the Fanatec solution for the DD Podium series that they have, those side mounts. So they have mounts available for those too. I've played around with this mount a little bit, and I've got some little bit of wear and tear you might see on it from getting it mounted and taking it back off. But yeah, it's definitely stiffer than the OEM one. Do you need it? Depends on the wheel you're going to be running when you get your cockpit. If you get one of these 6S80s, I would probably get this just because I like this type of mount more than I do the 2-piece bolt together piece that's on there now. Not that it doesn't get the job done, but still, I'm a little bit partial to these kind of things. Now, this thing, by the way, is welded on the top here, and of course, we have another bead on the bottom. So this is going to be very stiff, very strong piece here to mount any wheel that you have. So yeah, this would be an upgrade though, so you'd have to pay extra for it. So I just want to give you guys a quick look at these things as far as 6S, 6 Sigma, and what they offer as far as different wheel mount solutions. So here is the complete mount assembly, and it really wasn't too difficult. It went in pretty much as I planned. I just pre-loaded the T-nuts and the bolts over here on the side, and you can see them down in there. And it's just a matter of lowering them down into the wheelbase uprights, working that through. Wasn't too fiddly. They went in pretty easy actually compared to some of the other ones that I've done. So then it was time to come in and put the wheel mount itself on, and that was again pretty easy for those M8 bolts. And then we're all set, and now you can see it sitting here. The front bolt is slot in there on both sides, and that's so I can tilt this up and mount the wheelbase to it. It is sitting level. You can see my level there. So we can just take this and pick it up, and then I can get the bolts to the wheelbase I need in there. And then we can just slide it back down, get the other bolt in both of these slots here. And then once we're done with that, we can come in and do our final adjustment as far as what I'm going to do for height. Remember, we can come up, we can lean forward like this, and lean backwards. So I think it's not going to be hard to get what I want. Plus, I do have some adjustment here. I can push it backwards because you can see the position of the slots are all the way forward right now. And that's just the way it ended up. I haven't tested it or anything yet, so I'm not sure where that's going to be when it's all said and done. And again, pretty easy to do. Didn't have too much trouble at all. So there it is. There is the 6S-80 cockpit fully assembled. So now what we have to do is add some pedals, wheel, a seat, and give it a test. Here is our Logitech pedal set, securely mounted to the pedal deck. And this pedal deck was meant for these kind of pedal sets, the Logitech's, Thrustmasters, Fanatec, That's just what it's designed for. But I'm still going to be able to put some pressure on this plate because I have a true brake mod in this brake pedal, which makes it very, very stiff, and you can really push a lot of pressure on it when you're using it. So that's why I chose the Logitechs for this instead of my Fanatec's or my Thrustmasters, because this is the stiffest brake pedal I've got amongst those. Now, also, the Logitech pedal set, I have an adapter here. This is a Leo Bodner adapter. I did a review on this a long time ago. Basically, it's a USB conversion board molded into this plug here that you'll plug the pedals plug into, and then we can go in and connect the USB to our PC, and the PC will see this as a separate controller, so we don't have to hook it into a Logitech wheelbase, which is good because I'm not going to be using one. So I'm going to go around the bottom here, see if we can get a look at how the bolts are looking. Now, I don't have this secured yet because I don't know how far back or forth I'll be needing it, but we'll take a look under here, and you can see there's our M6 bolts. We have 4 of them securely attached on the bottom, and they have rubber feet on this too, so it really doesn't move very much when you put a lot of pressure on it. Once I tighten those down, it doesn't move at all. So we'll see how that performs once we're in and actually doing our driving. And yeah, you can see I have a pretty good angle on it because I like my pedals to be pretty much straight up and down, and that's about as straight up and down as you're going to get the Logitech pedals because they have such extreme rake to the rear. But again, we're just going to have to wait till we get the seat attached, and then we'll know where I need to put this as far as back or forth. So here's the wheelbase I'll be using for testing. This is a Moza R9. It is mounted to the top plate, and like I said before, they have hole patterns for the Mozas, and I don't know if that's a happy accident or if they meant to do that. But anyway, pretty simple to mount to this. What I did first is just set it on top like this with the back bolts in and tightened up a bit so it wouldn't flop around on me. You just can come in and install the pieces underneath like that. And then, because I couldn't reach the other bolts, you can just come in here and flip the whole thing up like this. And because I already had the front 2 ones on, it was easy enough just to get the bottoms in. They're all torqued down securely now, so I can go ahead and put the other bolt you see sitting there in the front slot on both sides, and then I'll be able to still adjust it back and forth, up and down, depending on where my seating position is going to be. And we're going to go ahead and get a seat on here so I can determine that. But yeah, this Moza's R9, it's 9 Newton meter peak, and I thought it was an appropriate wheel for this type of wheelbase to use. You could probably put an R16 or something in the 15 Newton meter range, I think, and this would still perform. I just don't know how stiff it is. I may put that flat deck that you already saw in the review, one of the optional wheelbases, on here with an R16 just to see how it responds. But I think it's going to do fine because remember, we're using these slot type T-nuts through all the connections here on this wheelbase structure. So really the only piece that could be flexing would be the profiles themselves, like in the middle here, but we'll have to wait and see how that works out. So I have installed the seat now. Everything is cinched down properly. All of my distances to the wheelbase and the pedals has been adjusted properly, and everything is cinched down tightly. I'm ready to go drive. Now, it was pretty straightforward the way I do my installations. I don't use sliders because I use these hex head bolts that I can get a ratcheting wrench in there and spin those pretty quick and just slide it back and forth on the profiles themselves. I did, as you can see, put these profiles in the flat position instead of standing straight up, which gave me a better reach and a better seating position as I address the pedals. And you can see, I think you can see the front one bolt in there somewhere. Might be able to see that. So yeah, pretty straightforward. My widths were 360 millimeters. My length was 330 millimeters. So once I had that set up and bolted down, yeah, the seat brackets went on like a champ. No problems. So again, everything is cinched down tightly. All my positions are where they need to be for a comfortable ride. And yeah, the only thing left to do is go ahead and cable up our controls and do some driving. We're in iRacing at Sebring, and we are in the Ferrari 488 GT3 Legacy car. So when I'm doing a review on a cockpit, what I'm really looking for is strength in operation. As far as when I'm in and driving it, what do I feel like? Do I feel flexy parts where it's causing some damping of my direct drive wheel, or is there flexing in the deck where my pedals are mounted, my seat mount? These are the things that I concentrate on or focus on as far as when I'm trying to do a review on one of these cockpits. Now, on this one, the wheelbase we're using, this is the OEM setup with a 4080 profile, and it's mounted to the 4080 uprights. And you can see in this, if you watch the corner of the upright, that's what I was using as a cue to see if it bent backwards or forwards when I was using this. And I can't see any movement. There might be just a little hair every once in a while, but I couldn't see anything that would be significant to me. Now, where I do see a little bit of flex here and again is in the actual mount itself, the OEM mount, the top plate where we're actually mounted the motor to. And I'm running this at full power, this peak 9 Newton meter motor here, and you can see a little bit of movement there, and I'm pushing hard. I use a pushing motion when I steer, so I'm not cutting it any slack, and I'm pushing it pretty aggressively just so I can see if it's going to get some movement out of it. So when I'm going around turns and you're watching the video, that's where I want you to look, is that top plate there, and there is some movement in that, but again, I'm at full power, and yeah, Sebring, a lot of bumps and things, so I was expecting to see a little bit more movement than this, to be quite honest. I was a little surprised when I was watching the video, because I can't see what I'm doing when I'm driving, obviously, so I have to go back to the video. And yeah, I was a little bit surprised to see that it was holding up so well as far as in the stiffness department. So I think they've done a good job here. And I'll talk a little bit as far as what it takes to do that. Now we're going to be looking at the pedal tray. And yeah, I know a lot of people are going to say, well, gee, you're just running a Logitech pedal set, Barry. But you have to remember, I do have the True Brake mod in this brake pedal. And I'm putting a lot of pressure on this brake pedal. And you can see it's not moving that far. Relatively speaking of a stock Logitech brake pedal, how far that thing moves. So this is a very stiff pedal relative, again, to this type of pedal set that you get from the Thrustmasters and the Fanatec's and things like that. I'm putting a lot of pressure on this, and I'm not seeing any movement in the pedal tray at all. It's inclined way up too, so you know it's not at a heavy support position when it's up in the air like that. It'd be better if it was down flat, but of course with the rake on these pedals, I can't drive with them like that. It's like a truck driver position. Speaking of that, the position that I'm using here, I was able to find a very comfortable position. I didn't feel like I was in the truck driver position. Now, I did take the 4080 profiles we're using as seat rails and lay them flat to lower the seat down another 40 millimeters. So that helped, obviously. And the fact that the pedals are up on that pedal tray and they're at that angle is actually a pretty comfortable sitting position. I was a little bit surprised by that too. And the seat brackets themselves doing their job. I don't feel any flex in it when I'm pressing on the brake pedal or I'm holding onto the wheel real tight. When I push, when I'm turning and I'm pushing, I'm actually pushing my upper body, the shoulders, back into the seat when I do that. And I would be able to tell if there's any flex in the connection or the profiles themselves where I have this thing bolted down to. And yet nothing there, so that makes it more comfortable too, because when you're pressing on a stiffer brake pedal like it's on, like I said before, that's on this Logitech set that I have, that, yeah, it makes it more comfortable in the small of your back if it's in that pocket down there in the seat, properly positioned. Yeah, it takes a lot of stress out of your lower back when you're constantly hitting that brake pedal over and over again. So I think that Six Sigma has made the right choices here as far as how to build a cockpit and make it as stiff as possible, considering the materials you're using. I mean, just a 4080 profile, that's what I would consider a minimum starter cockpit that someone would want to get. 120 or 160 even better, because that would be an in-game cockpit and you would never have to worry about moving up to something else if you decided to put, a 6-inch motion system on your cockpit later on. Now, again, credit to what they've done on their part selection here. These very large 8-bolt corner brackets, gusseted corner brackets with the anti-twist elements in them. Very good choice. Using the slotted T-nuts with their, which will have a lot more surface area contact with the profile than the usual ones you get, which are the spring ball, or in this case, because it's the Chinese source profile, the leaf spring type of T-nut. Yeah, once you bolt 8 of these down in the joints of this is one of the reasons why we're not seeing motion where I thought I would, or movement where I thought I would. So yeah, good part selection there. And I think for the OEM wheel mount, there's only so much you're going to get at this price point. And remember, they do have a flat deck or CNC bottom mount, they call it, that you can pay a little extra for and get that. And you would not see the flex that you see in this top plate of this plate assembly that we're mounting our motor to. So yeah, even though I don't think it's that much movement that really makes a difference, what really I was concerned about is the uprights moving back and forth as I'm pushing on the wheel. And again, I think if you can watch this video, you may see it move. I keep missing it when I think it moved. I go back and look and it didn't. And I'm using the corner reference to the 4080 upright in the background to see if that line is moving at all when I'm using it. So you might want to look at that point too, the corner of the upright over there that has that profile in the background. That's what I was using as a reference point. Anyway, a very solid rig here. For $500 plus your shipping, I think this is a solid unit. It comes with everything you need. You can get a shifter mount for it if you want, and that's the typical 4080 with the 140/40 on the back support that you see on most type of these profile cockpits. So obviously there's other accessories available. You have to go to their website and look at it. But I think, for a $500 plus shipping, and this is in Canada, so it's a North American sourced cockpit instead of going from Europe, which obviously the shipping's going to be a little bit more expensive. As far as final cost, that depends on obviously what you're buying and who you're buying it from. But I'm really having a hard time considering the price point and what this rig is intended for of complaining here. It's a very solid rig once you bolt it together using those T-slot nuts, and yeah, I just can't complain about that. I think, for the money, it's meeting the expectations and actually exceeding it in a couple of places for me personally. Final thoughts on the 6S80 cockpit from the guys at 6Sigma. The cockpit is constructed of 4080 profile extrusion. It has a deep channel profile commonly found on China-sourced profiles. The finish is black anodized. Out of the box, the profiles look to be in good condition. All the required hardware and fasteners were present in my kit, so no last-minute trips to the local hardware store to source a missing piece. The hardware for assembling most of this cockpit are M8 steel bolts with a wide slot type of T-nut. I think that 6Sigma has made the right choice here to ensure that their assembled cockpit is as sturdy and stiff as it can possibly be. This is the first sim racing cockpit I've seen that includes this type of T-nut. Usually you get a bag full of the spring leaf type T-nuts that are used throughout the building process. There is a piece of spring steel spot welded to the side of the T-nut. This allows the T-nut to press against the underside of the channel's edges, and it keeps the T-nut from sliding around in the channel, along with the ability to be inserted directly into the channel at any point on the profile. The slot-type T-nut must be inserted from the end of a piece of profile. So you need to plan ahead if you want to mount anything else to the same profile and insert the required number of slot T-nuts to secure the mount. Or just use the spring leaf type T-nut for something that you need to attach to your cockpit later on. However, the slot type of T-nut has a noticeable mechanical advantage over the spring leaf or spring ball T-nuts. Easy to understand once you see how much of the profile's channel surface area is being clamped between the two different shapes. Of course, building your cockpit with a slot T-nut will result in a more secure and stiff joint, which translates into a more solid structure using the same material than the smaller T-nuts will. This is the reason I use the same style of T-nut, albeit with a spring ball element, on my personal cockpit builds in the major joint areas. Once I had the cockpit assembled, it was time to attach a seat, wheelbase, and pedal set to see how it performed. During my driving sessions, I did not notice any flex in the cockpit itself. The pedal deck did not deflect under braking pressure from my True Brake modded Logitech pedal set. This mod adds a lot of stiffness to the stock brake pedal, which requires much more pressure to use than the stock brake pedal. Even so, no movement was felt underfoot or seen in my video footage. The wheelbase mount that the 6S80 cockpit comes with was solid enough for the 9 Nm peak torque motor I was using. Six Sigma does offer motor mount options for those running more powerful motors. The top plate where the mounting bolts were holding the motor case did have some minor deflection. At the same time, I was surprised to see no deflection or movement from the 4080 wheelbase support uprights, which I normally see with these type of profiles. Another testament to the clamping power these slot-type T-nuts have over the normal, smaller T-nuts. The seat rails also delivered a solid feel when driving aggressively. I was able to find a comfortable GT-styled seating position with the adjustability here, avoiding the truck driver position that many entry-level cockpits have. At $500 plus shipping, I think the 6S80 meets my expectations and even exceeds them in some areas. I'm Barry Rowland. Thanks again for watching the Sim Racing Garage channel. Don't forget to hit the subscribe button. And if you would like to help support what I do here at the SRG, visit my website at simracinggarage.com.